All right, so task number 7, interactive line on our beginner Desmos activity to level up our Desmos skills. What we're doing here is, here, let me open this thing up there, is that we're going to use sliders to control some aspect of a graph. And the reason why this is important is because let's say I have myself an SAT question. I know that there is some sort of equation that's in there. Desmos can graph that for me pretty easily, but I don't know how changing one of the numbers is going to affect that graph. Well, I can create some sliders and make my equation using those sliders so that I can very quickly do like a little investigation to gain some information that might be able to help me answer that question. So it all starts with making sliders. As a matter of fact, you can do this kind of backwards. So you can start with the sliders and then make your equation based on those sliders, or you can do this kind of in the reverse, which I'll show you and at the very, very end, is that you can start with your equation that has some letters that you haven't used, and then it will auto-populate or ask you if you want to make sliders for those things. I'll show you both ways. So I'm going to start with a slider. It says make a slider for the slope. If you look down here on box number 50, it says we're doing a slope-intercept form, so it makes sense that we need slope. Slope is usually an M kind of thing. So I'm going to do M, and then an equals, and then you just choose any number that you want to. I'm going to just choose 1. And right now, before I hit enter on this thing, it allows me to change a minimum value for my slope, a maximum value, and what I want it to go up by. That's the step size. So I am just going to use the defaults, and the defaults go from -10 to 10 for the minimum and the maximum, and the step size, I'm going to leave it blank. That way it can change in between numbers as decimal numbers if I wanted to. So I'm just going to go down to box number 49 here, and then it's going to make a slider. And now whenever I move my little slider, it does a whole bunch of nothing. Sure, my M value changes, but it's not doing anything on the graph because I haven't attached that M value to an equation yet. We'll see that in a minute. Okay, so now let's do the same kind of thing for the slider for the y-intercept. So for my y-intercept here, what's traditional? Oh, yeah. What's traditional is usually a b. So I'm going to do a little b. I'll do the same thing that I did before. B is equal to, just pick any number. Maybe I'll make it a 2. And I can change again, minimum, maximum. Maybe I only want positive numbers or whatever. Maybe I want it to go up by just integers. So I put like a 1 right here instead. I don't want any of that to be true. I want it to be anything possible. So I'm just going to click down here, and now I have a slider for my y-intercept. And now what I want to do is type myself an equation using those variable names, the m and the b. Now, a mistake that some of us made actually was, oh, I can see my slope is -3. Watch this. I'm just going to type in y is equal to -3x. And then I can see my y-intercept here is -1.5. So I go -1.5. Awesome. I have my line. It used the numbers in the slider, but the problem is if I move my slider, it does not affect my line whatsoever. So if I wanted to affect my line, I need to use the m in there where the -3 is. I need to use the b where the 1.5 is. So here, let's take a look. Let me delete some of this out. And let me just put the m in front of the x so that we can see what the heck that does. So m and then x. Right? And I didn't even use the y-intercept yet, so it's going through the origin. And now if I click on my little slider here for my m, whenever I change this, it makes it steeper, less steep, makes it so that it decreases instead of increases, right? So you can see the value in being able to change this thing on the fly and see a whole bunch of different versions of this line by just dragging your slider. All right, so now I'll add in the y-intercept. So I'll hit my little plus. Don't type in the number, but instead type in the letter. And I bet this is going to do something on my screen that it did to you on yours. So this was a thing, like a little obstacle many of us probably had to overcome. Notice that it didn't graph the line. The line actually disappeared. And that there's a little warning triangle to the left of my equation there on number 51. And if I click on that little triangle, it should tell me what the error is. And it says you've defined B in more than one place. Try deleting some of the definitions of B. So you might have in one of these other tasks here, use the letter B for a slider. As a matter of fact, I'm pretty sure I did that up here in number 4. So watch, I'm going to open up number 4 and notice that I have a B slider here that says 40. Okay, and then down here I have a B slider that's negative 1.5. So Desmos is like, well, which one am I supposed to use? I can't use them both. I'm not going to like average them. So what you just do is you just change one of the variables or you delete the other slider. So the easiest thing here is just to change this B in this instance up here on number 4. Maybe I change it to something like a D. And now, did you notice that the line just popped up? The reason why that line popped up was because now it was free to use the B. And of course, if I move my B to the right and to the left, what it's doing is that it's taking my line and moving it up and down the y-axis, right? I'm changing the y-intercept. All of this, like I said, is super valuable. Now, you probably already knew those things about a line, changing the slope, changing the y-intercept, but what we're talking about is using it in instances where I need to do a small little investigation to try to figure something out that I didn't already know. All right, and let's say, for example, I do that right now. Let's talk about some another kind of graph that you learned about last year, like an exponential one, for example. So I'm going to go down to 51, just add an extra little box in here. Let's turn off the line, and I'm going to use the same exact sliders that I have right up above here. I'll use the little m. So I'm going to start with the parent function y is equal to 2 to the x. So that's the exponential function with a base of 2. All right, and let's say that what I wanted to do is see what happens if I put myself a coefficient in front of the 2 through multiplication. And I'll just use the m that's there. So I'm going to go right in front of the 2, and then I do a little m, and then do a little multiplication here, times. And now whenever I move my little slider, I can see what does that do to my graph. And you can see it makes it steeper if I make it bigger. Closer to 0, it's flattening out. And then, of course, if I make it negative, it flips completely over the x-axis, right? All right, and then let's say that I wanted to add the little b in here because this is the generalized form of these exponential equations. You have a plus b, and that affects something too. Let's see what the heck that affects. So if I put a b, notice that it just shifted the thing up. Let me move my little b here to something. Let's see, and move it to hole number 4. Look on the graph. 4 is where this thing is kind of bottoming out. You remember that's called the horizontal asymptote that this thing is trying to approach. As a matter of fact, here's another cool thing that I can do. Like, that's a horizontal line. It should be y equals whatever that y value goes through. So if I go to an extra line down here and go y is equal to, instead of typing in a 4, I'm going to type in the b that I used for my slider there, b, and then since this thing is an asymptote, not part of the graph, maybe I dot it or something, dot it or dash it. Yeah, that looks pretty cool. All right, hit done. And now watch this business. So if I move my slider for B, it's going to move that horizontal asymptote with it. If I move M, notice that it doesn't move the horizontal asymptote. It becomes like the new x-axis here that this thing is trying to get closer and closer to. That's what that whole idea of the asymptote is all about, right? All of this. Super powerful and very easy to do as well. All right, now I'm going to show you the second version or the second way to make sliders. I don't always start with my sliders. A lot of times what I do is I start with my equation knowing that I want sliders in there. So what I'm going to do is I'm going to write an equation or type in an equation, maybe let's do a quadratic. And I'm going to include letters that I haven't used before because remember, we've already come into the situation where if I use a letter that I already have defined before, it's going to try to pull that one or get confused completely. So I want to avoid that. So I'm going to use some weird letters here. So y is equal to, and then I want a coefficient on my x squared, and I haven't used, let's see, I haven't used u, so I'll use u, and then an x squared. And can you see what's right down below? It says add slider. I'm not going to hit it just yet. And then I'm going to do plus, and then I need a coefficient on the x term. So I haven't used q. So I'll use a Q and then an X. And then I need a constant term here. So I'll do a plus. And then let's see what I haven't used a P. That's good. And now notice what appears right down below. It cannot graph this because U is not defined, Q is not defined, and neither is P. It needs those things to be defined in order to graph this thing. So it's going, can I make sliders for these? Which will assign numbers for them, and then you can change them. So you can individually add sliders by clicking each letter, or you can click the little all, and it'll make a slider for all three of them. And now I can interact with every aspect of this graph. Once again, these are super handy things to know so that maybe it enables you to do some complicated things you couldn't otherwise answer on a test like the PSAT or SAT.